Hello YouTube. Today I'm going to be showing you guys how to solve 2 sum 2 and the input array is sorted. So first thing, just as a overall steps for all problems in a technical interview is read or read/understand the problem to the fullest. Really read the problem, understand what it's asking for and what you want. After you do that, after you try to understand it or read it to the best of your ability, ask the interviewer any questions that you may have. Asking him questions shows the interviewer that you're interested in the problem and you're interested in how vague the problem is and you want to clear some of that vagueness. Sometimes interviewers will give you a problem that's vague and they'll give it to you like that on purpose because they want to see how good you are at problem solving. After you do that, you want to what helps me personally is either go on a whiteboard or kind of draw a diagram of the problem and then draw a solution. And then after that, it's time to do code work. So now let's read the question. Given a one index array of integers, numbers, that is already sorted in non-decreasing order. So it's in strictly increasing. It's important to remember. Find two numbers such that they add up to a specific target, which it looks like the target is given right here. Target number. Let these two numbers be numbers at index and numbers at index where the index is always greater than 1. No, where the first... Oh, okay, so it wants us to put the first index first, the second index, and then those are both in between the index length. Return the indices of the two numbers, index 1 and index 2, added by 1. Okay, so it wants them to kind of be normalized as an integer array of length 2. Okay, the tests are generated such that there is exactly one solution. Okay, so what this means is we can return a solution right when we find it. You may not use the same element twice. Okay, so they give us 2, 7, 11, 15, and the target is 9. So for this problem, we're given 2, 7, 11, and 15, and the target is equal to 9. So now what I'm thinking the best way to solve this problem would be to kind of have a low pointer and a high pointer. And what we can kind of do is we can start the low one at index 0, the 0th index, and then start the high at the last index, and then we make a sum that equals low plus high, and then we make an if statement that says if the sum, first off, ideally, if the sum is equal to the target, then what we do is we just make the array that we're gonna return, and then return it. Now, So what we're kind of going to do is if the sum is higher, if it's too high, if the sum is too high um, compared to the target, then we're going to increment the high pointer low. Now, if the sum is too low, we're going to increment the low pointer up until we eventually get one that equals the target. So then we do, if the sum is less than the target, then we do low plus plus. Now, if the sum is greater than the target, we do high minus minus. And all this is going to be inside of a while loop. So that's kind of the overall solution that we're going to try to implement. Now, what we can do now is start with the coding work. So, like we said, we're going to do a two-pointer method. So int low is going to equal 0, and int high is going to equal numbers dot length minus 1, because when you subtract it from 1, that's when you're getting to the last index. Now we need a while loop. While low is less than high, we want a sum value. So we want the sum to equal numbers at low plus numbers at high. Now what we can do is we can do if the sum is equal to the target, then what we can do is we can make a new int array and call it answer, and equals it equals low plus 1, and the second index is high plus 1, and then we then return this newly created array. Now else if the sum is less than the target, then what we can do is we can increment the low to go higher, and then else if we can if the sum is greater than the target, we can increment the high to go down. And then after that's all done, so ideally we will eventually, without fail, get to this, because there will always be one solution. So it really doesn't matter what we return. So we could just return null here. And this code should work. Oh, I misspelled high. So now a few ways, so we can try to submit it now, make sure that it passes all the test cases. Okay, so now a few ways, so forgot to mention, when you before you start writing your code, you need to make sure that the code is readable and easily understandable. That's really important. Now, after you do the coding work, you want to make sure that the tests pass. And also at this time, you want to, well, maybe around when you're drawing a solution, you need to, it's really important to think of the edge cases. I really should have mentioned this sooner, but it's really important to think of all the possible edge cases. The reason I didn't mention it in this case is because it didn't really seem like there were any edge cases because it looked like it had it covered with the index always being at least one. At least like having one thing, and it wasn't just going to give you an empty index, and it also um, exactly there's always exactly one solution. So there weren't really any edge cases. They kind of cleared that out. Um, but a way to take care of the edge cases would be if numbers dot size equals 0, then we could just return um, return maybe we could return an empty uh, we could just return numbers, something like that. We'll just return the same thing back. But this should never occur, so it will still oh, this is dot length. This should never occur, so it should just always pass. So after your tests pass, you want to read over your code with the interviewer and try to make any optimizations. Whatever, optimize it. Is that how you spell optimize? Yeah. Okay. Wow. So yeah. So make optimizations. So now what we can do here is just look over the code, kind of try to make any optimizations. So one I think what we can do is we can say less than or equal to, because we don't if they're equal to each other, we're looking at the same element. So it should also pass this, and it should pass everything, and we're going through one less iteration. So it is a little bit quicker. Also, what I'm thinking we could do is after we have this, we can just continue. And we can or we can maybe break. Let me see if this should work as well. Okay, then. I think continue is the one that we're looking for here. What this basically does is it makes us, when we hit this, it goes back into the while loop. So it should be a little bit quicker. And I think that's pretty much most of the optimizations for this one. Now that pretty much concludes the video on how to solve 2-sum 2. Thank you for watching.